Hey, so we're going to take a look at a tool I made to try to make some things, I hope, clearer as it relates to polar equations. So one of the things here is when we see a circle, we know that this is from a sine function, and we can see in a polar system it makes a circle, and in a rectangular system it makes a wave. And I can track a point over here, and that's how this was designed. So as I go through one orientation of that point, through one kind of cycle of going through 2 pi, so I get my full sine wave here, I can see that it goes around the circle twice. And this creates a really good opportunity to have some conversation around, well, what's happening when the points over here, if we look at this transition point, we completed one rotation there, but now, as we're going down here, the points are negative, right? Because the values are negative, and the same would be true in the polar system. So as those points are negative, as the angles get larger, they actually get plotted going backwards because they're negative. So it ends up spinning around the circle again. Instead of being those negative values, they just get projected backwards. So if you try to think of it as we move through the wave, over here, we've got one cycle through for the circle. Now the values are getting negative. So I might have expected it, at least initially, to reverse direction or to do some other interesting phenomenon. But really what happens is as those become negative, I'm thinking about angles over here, and the values get projected over onto the space where it repeats itself. And that was something that I wasn't necessarily totally tuned in with when I first experienced polar systems. The next type of equation we might want to look at would be a polar rose. And so with the polar rose, we have this leading coefficient over here, which I'll shift. And let's say look at a polar rose with 4 petals. So the part of the question is, why are there 4 petals? And the answer, as we track the movement of a point through space, is that we can see that in this context, as the point moves, and it gets expressed because the 2 full cycles of the sine wave are happening in the same domain. In this case, it's 2 pi. What happens is that instead of being a circle, we make these petals. And it's really a function of things that we wouldn't necessarily expect, but that if we can visualize it at the same time, they become a little clearer. So again, let's take a look here. We can see that as the point is moving through the rectangular plane, it's now expressing itself as the petals of the rose. So I hope this video helps. You can experiment. There's loads of interesting phenomenon to look at. In particular, if you pick values that are not whole numbers. So for example, instead of 2, we use 1.6, and we trace through this. You can see that it doesn't quite fit, the domain doesn't quite capture everything. We can see here that the cycles don't fit. But it creates a different phenomenon with these gaps, which is pretty fun. And we can change it to make them more or less, and you can kind of get a sense for how some of these are being compressed and expanded. It's just a great way to build some intuition around polar systems. So I hope you enjoy it, and I hope you have some fun discovering something interesting to you.